Hello. Am I audible?
हाँ जी भैया।
Okay. So, कल तक हम क्या कर रहे थे? I mean, what we were doing till yesterday was some questions on limit and continuity. So let us start our discussion from there itself. Okay. So let's say what we were discussing last day was about limits and continuity. So limits and continuity in complex analysis. Okay. So I told you that when it comes to limit and continuity, you have to see whether or not your limit is path independent. Okay, so you have to see that your limit should be path independent. First thing is path independence has to be ensured. See what differs, like in one variable you don't have to do all these things, but in complex analysis, because complex analysis carries with it the character of a multivariable calculus, so you have to ensure that your limit should be path independent. In this regard, I told you, let's say for example, if we have to see that your limit at some point exists, let's say limit z tends to z naught if z exists, then first point is that limit must be unique. And by uniqueness, I would mean path independence. Path independence. Okay. So here it should mean path independence. And similarly, if I talk of continuity, independence. Okay. So if I talk of continuity, what does it mean? It also means that your limit should exist and limiting value should be equals to the value of the function at that point. So I told you that in order to say that a function is continuous at a point, let's say z naught, function must be defined at that particular point z naught, because if it is not defined at z equal to z naught, then function would cease to be continuous. So remember this fact, for function to be continuous, it must be defined at for function to be continuous, for function to be continuous, function must be defined at, say, let's say z naught. I'm saying function must be defined at z. So if at all you have certain function which is not defined at a point, then it is not continuous at that point. You can straightway say it. So function must be defined at z. Okay, I hope this is clear to you, everyone. Okay, now let us go to something called as analyticity. Okay, and or let's say first start with differentiability. Okay, let us first start with differentiability. So if I'm saying, what do I mean when I say a function is differentiable, a complex function is differentiable? So what do I mean when I say a complex function is differentiable? So this is what we are doing. And at the very central theme of our discussion, especially in complex analysis with regards to physics people, we would stick ourselves to analytic functions, like very well-behaved function. What do you mean by well-behaved functions, or what is an analytic function? We'll discuss lately. So shortly. So the point is this: key, in any case, you have to go through differentiability, and only then I can move on to analytic functions. Okay. So in any case, for a physics person, the concentration should be on analytic function. So therefore, it holds a very central theme in our complex analysis discussion. Okay. So let's say, what do we mean by when I say differentiable? So let us move our attention to one variable calculus. So in one variable calculus, if I used to say my function is differentiable, and let's say if I'm defining the right-hand derivative, what it used to be this kind of thing, right? So if I say your function is differentiable at point x naught, if I say my function is differentiable at x naught, then this limiting value, that is f of x naught plus h minus f of x naught upon h, and limit h tends to 0, f of x naught minus h minus f of x naught divided by minus h must exist. This we used to say left-hand derivative, and this we used to say right-hand derivative. Okay? Yes or no? अरे somebody say yes or no. दीक्षा आई क्या? दीक्षा आई बेटा?
Yes, sir.
है ना? ठीक है.
Yes, sir.
Okay. So if I say that my function fz is differentiable, that is fz, if I'm talking in complex functions, the same goes here also. The only point is, if I say my function is differentiable at, let's say, point z equals to z naught, then what I have to do? I have to find this limit. Limit delta z tends to 0, f of z naught plus delta z minus f of z naught divided by delta z, where delta z tends to 0. So if I say my complex function fz is differentiable, I would mean that this limit should exist. So if my function is differentiable, then this limit must exist. And again, the same condition, that limit exists and it should exist uniquely. By uniquely, I mean in any case, my limit should be path independent. It should not be path dependent. If at all it is path dependent, then my function ceases to be differentiable at that particular point. So by uniqueness here, I would mean path independence. Are you getting my point? यहाँ तक समझ में आई बात?
हाँ जी भैया.
Okay, ji. So let us start. Let us look at this particular thing with respect to some example. Okay, so let us take an example. Let's say fz is equal to let's say x plus 3 iota y. I don't think anybody would have issue with this kind of function. Okay, so this is the function. Let us see whether or not function is differentiable. Let us see whether or not function is differentiable at any point. Let's say x comma y. So at any point x comma y, yeah, you take x naught comma y naught so that it doesn't disturb you. So let us take any point x naught comma y naught, and let us see whether this particular function is differentiable or non-differentiable. So I'm assuming any arbitrary point x naught comma y naught, and I'm seeing the differentiability of this particular function at any point x naught comma y naught, and let us initiate. So according to our definition, what we know that if function is differentiable, then this limit must exist uniquely, isn't it? So this limit must exist uniquely, yes or no? So let us find whether or not this limit exists uniquely. So this is how it is. Okay, what will be what is delta z? Delta z would be equals to what? Delta z would be equals to delta x plus iota delta y. Okay. Okay, any issues? I don't think anybody would have any issues. Okay, so let us do this particular thing. So what we'll get is we'll get f of uh, this would become what? This would become, so if I place instead of z naught, if I place x naught comma y naught, so here it will be equals to what? Here it will be equals to x naught plus delta x, okay, plus 3 iota y naught plus delta y. Yes or no? Okay, so instead with z naught you're adding delta z. Delta z is this. Okay, delta z is any increment in any general at any general point. Let's say this is your x naught comma y naught. You want to give an increment of delta x to it and also delta y to it. So most possibility is lying somewhere. So this, let's say any point is x naught plus delta x comma y naught plus delta y. So by z naught plus delta z, I mean this. So what it would do, instead of x, you have to write x naught plus delta x, and instead of y, you have to write y naught plus delta y. I hope I'm even understand this particular point. So, and what is fz naught? Fz naught will be simply x naught minus 3 iota y divided by delta x plus iota delta. Any issues till now? So delta z tends to 0 would mean delta x tends to 0 and delta y tends to 0 simultaneously. So delta z would tends to 0 would mean delta x should tend to 0 and delta y should tend to 0. Yes or no? This gets cancelled with this. This gets cancelled with this. So eventually what you are left with delta x, I think, and plus 3 times iota delta y divided by delta x plus iota delta. Yes or no? Now, what about this limit? This limit, whether it is path independent, path dependent, how to assess? So let us take two simple cases. You can take y equal to mx also, but in order to visualize it better, you can take two cases. Let us take two specific cases. You can take y equal to mx. I have no issues. Just to tell you, in order that you get to know it better, I'm just doing it. Let's say if I'm approaching delta x and delta y tends to 0, such that your delta y is 0. Let's say delta y is 0. Delta y is 0 means what? डेल्टा y 0 means y must be constant. Y कब constant होता है? Y constant होता है when you are approaching along x axis, right? Because x axis पे y constant होता है, y axis पे x constant रहता है. Yes or no? या फिर any line parallel to y axis, your x would be constant. Any line parallel to x axis, your y would be constant. Yes or no? हाँ या ना बोलो बेटा. So let's say your point is x naught comma y naught, and you are approaching it in this fashion. So if you're approaching it in this fashion, your delta y would be 0. Yes or no? You are moving parallel to x-axis. When you're moving to parallel to x-axis, your y is a constant, isn't it? So if I say plot me a diagram of y constant, so you plotted this fashion, you plot it in this fashion. No? So if y is a constant, then delta y has to be 0. Yes or no? So if you are moving parallel to y-axis or parallel to x-axis, your x would change. X would change certainly in a manner that you approach x naught comma y naught, but your y remains to be equal to y naught. Yes, so delta y is equal to 0. वापस बोलूं मैं बात, देखो x naught comma y naught को approach करना है, there can be infinite ways, this way, that way, this way. I'm just using two simple ways. This would be my path 1, this would be my part 2, so that you would better understand this particular thing. So let's say if I'm moving along the path 1, what will be the equation of path 1? So I'm moving this way. So basically ये क्या पॉइंट है, x नॉट कॉमा y नॉट, इसके along अगर ऐसे चलूंगा तो ये लाइन की इक्वेशन क्या हो जाएगी, y इक्वल टू y नॉट. और अगर y इक्वल टू y नॉट है तो y कांस्टेंट, तो डेल्टा y क्या होगा, 0. डेल्टा x कुछ होगा, आई डोंट नो व्हाट, बिकॉज जैसे जैसे तुम अप्रोच करोगे डेल्टा x कम होता जाएगा. और इस लाइन के along यू सी डेल्टा y कुछ होगा, लेकिन डेल्टा x 0 होगा, क्योंकि देखो ना इस लाइन के along x कोऑर्डिनेट क्या है, x नॉट ही रहेगा ना. थ्रोट देखो इस लाइन में x कोऑर्डिनेट थ्रोट x नॉट नहीं रहेगा. सब बोलो, सब, वेयर आर यू एवरीबॉडी?
हाँ जी भैया.
दीक्षा समझ में आया बेटा? कहाँ गई दीक्षा?
यस सर.
है ना, मैं दीक्षा से क्यों पूछता हूँ ना, क्योंकि शी इज द यंगेस्ट ऑफ ऑल, है ना, तो अभी उसको समझ में आ रहा होगा तो मतलब सबको समझ में आ रहा होगा. दिस इज व्हाट आई अज्यूम. आई डोंट नो, आई एम नॉट वेरी सर्टेन, बट दिस इज व्हाट आई अज्यूम. ठीक है. सो देखो, लेट्स से पाथ 1 के अलोंग मूव कर रहे हैं. लेट्स से हम पाथ 1 के अलोंग मूव कर रहे हैं. इफ आई मूव अलोंग पाथ 1, I have said that delta y would be 0, so delta y goes 0, so this limit would be equals to 1. So in this case, limit would be equals to what? 1. And if I move along path 2, if I move along what, path 2, this is my path 2, here delta x is 0. So if delta x 0, delta x 0, what I am left with 3 iota delta y divided by 3 iota divided by delta y, so I am left with 3. So limits are different, limits are not unique. So therefore, this particular function, that is x plus 3 iota y, is a non-differentiable function. In fact, you would see that I have taken any general point. Let's say x naught comma y naught, I have not put 0 comma 0 or anything. I'm saying any general point. So it is not differentiable on entire complex plane. ठीक है. So it is not differentiable on any entire complex. समझ में आई मेरी बात? हाँ या ना? Because देखो, x नॉट कॉमा y नॉट कोई भी आर्बिट्री पॉइंट था ना, इसमें मैंने ये स्पेसिफाई तो नहीं किया इसको 0 0 ले लो, 1 0 ले लो, 0 1 ले लो. नो, आई हैव टोल्ड दैट इट कैन बी any ordered pair in the complex, any ordered pair on R square. So any ordered pair on R square, if I say that my function is non-differentiable at any point, that implies it is not differentiable on the entire complex. Yes or no? Everybody is getting my point. भरत को समझ में आया?
यस.
अल्पना को समझ में आया?
हाँ भैया.
गोपाल को आया?
यस सर.
प्रज्ञा को आया?
यहाँ भैया.
ठीक है, ठीक है. सो ये सारी चीजें हो गई तुम्हारी. ठीक है. अब हम आते हैं मेन चीज पे, जो हमारा मेन फोकस है ना. सो याद रखना जो मैं लिख रहा हूँ वही है. ठीक है. सो दिस इज योर कॉशी रीमन कंडीशन, एंड दिस इज सुप्रीमली इंपॉर्टेंट व्हेन इट कम्स टू योर फिजिक्स पार्ट. ओके. और एक लेक्चर हो सकता है पॉसिबली आई वुड गिव यू ऑन कॉन्फॉर्मल मैपिंग एंड मोबियस ट्रांसफॉर्मेशन, and one lecture on analytic continuation. Probably they are not in your syllabus, but they will form some sort of motivation to you, because otherwise you won't be able to get any sort of motivation as to why complex analysis, why we are studying complex analysis. So why in physics we are studying complex analysis. So that would also come. So that you'll have to keep patience, because probably that is not an exam syllabus, but otherwise it is good. ओके, सो देखो कॉशी रीमान कंडीशंस के लिए अब एक चीज हमने पढ़ ली कि फंक्शन का डेरिवेटिव कब एग्जिस्ट करता है. दिस इज वी आर क्लियर विद. नाउ वी आर मूविंग टू कॉशी रीमान कंडीशंस एंड लेट अस कंसीडर एनी सच फंक्शन whose derivative exists. Let us consider any function whose derivative exists. So whose derivative exists. So it implies we are considering a function which is differentiable. Okay. So we are considering a function whose first order derivative exists. Okay. So we are considering a function whose first order derivative exists. So if we are considering a function whose first order derivative exists, there are certain conditions which are called as Cauchy-Riemann conditions. There are certain conditions called as Cauchy-Riemann condition. I'm not getting into the derivation part because that will be not lengthy, but probably you are not aware of how to evaluate first order partial derivatives. If you're aware, I can go ahead with that. If you're not aware, let us just write it for meanwhile. And possibly I will give you another video lecture on that particular thing, probably a short video, and put it on today itself, how to derive it. But for that, you should know what is partial derivative. So that is a big problem. So that I would do anyway. So let's say my function is written as u plus iota v, and this particular function is differentiable. That is, the derivative of this particular function exists. Then there are some conditions which are called as Cauchy-Riemann conditions on real and imaginary parts. So there are some conditions called as CR conditions. Then it implies that CR conditions on U and V are met. What are those conditions? The conditions are that del U over del X would be equals to del V over del Y, and del U over del Y would be equals to minus del V over del X. So these are the conditions which are satisfied if your function is differentiable. So if f is differentiable, that is f dash that exists, that and fz is equal to u as a function of xy plus iota v as a function of xy, then the Cauchy-Riemann conditions are met. Okay, let me try to give you sort of an idea to it. Possibly you'll be able to get some. Okay, so why not discuss this also? Okay, so I'll write it somewhere here. So एक चीज समझो कि अभी तक what we were discussing derivatives. Even in your real analysis, you are quite aware of derivatives. Now there is something called as partial derivatives. And why they are needed? They are needed because in certain direction we have to see the rate of change. Let's say the temperature field. So temperature is a scalar field, and let's say temperature in the room which I'm sitting presently, or probably you are sitting, or depends on x, y, or z. Okay, so where you are sitting depends on x, y, z. For example, there is a beach, there is a mountain. You climb up to the mountain, the temperature would change. So you change z, your temperature would change. You come down to beach, there is a sea around. So you come down to the beach, temperature would again change because again it is a function of x, y, z. Okay, so you go up in the atmosphere, again temperatures is a scalar field which changes with these coordinates. Okay, so x, y, z. Okay, so possibly I could say that my temperature would vary with x, with y, and with z. So if what to do if I have to say that my temperature, how does my temperature vary along x? How to say my temperature varies along y, and how to say my temperature varies along z? In order to know that, we need something called as partial derivative. Okay, so if I'm saying my function is of two variables, let's say for simplicity I'm writing of two variables. So let us define a function of two variables. Let us define a function of two variables. And if I have to say what will be the partial derivative with respect to x, so partial derivative with respect to x will be f of x plus h comma y minus f of x divided by h and limit h tends to 0. Understand the fact that in evaluating this particular limit, I have only given an increment in the x-axis, not in the y-axis. So basically, along y-axis, I'm not giving any increment. In the x-axis, I'm giving the increment in order to capture the rate of change of the function along x-axis. समझ में आई मेरी बात? ये मैं इसलिए कर रहा हूँ बिकॉज आई थॉट कि कौशी रीमान एक बार मैं थोड़ा सा एक आइडिया दे दूं. आर यू गेटिंग माय पॉइंट? नहीं आ रहा तो प्लीज पूछ लो.
भैया एक बार पार्शियल डिफरेंशिएशन वाला वापस रिपीट करना.
ओके. सो पार्शियल डेरिवेटिव, देखो मेरी बात समझो. पार्शियल डेरिवेटिव का मतलब क्या है? आप एक पर्टिकुलर एक्सिस के अलोंग डेरिवेटिव निकालने की कोशिश कर रहे हो, राइट? मैंने एग्जांपल के तौर पे दिया, मान लो तुम बैठे हो बीच पे, राइट? यहाँ पे बीच है, ये बीच रहा तुम्हारा, और जस्ट बीच से सटा हुआ कहीं माउंटेन है ना? ऐसा कोई बीच मान लो, आई डोंट नो कहीं एग्जिस्ट करता होगा तो करता होगा. सो लेट्स से दिस इज अ बीच, दिस इज अ माउंटेन. सो इफ यू आर स्टैंडिंग हियर, टेम्परेचर वुड बी सर्टेनली डिफरेंट बिकॉज यहाँ ह्यूमिडिटी ज्यादा है एंड देयर आर डिफरेंट अदर फैक्टर्स, एरिएशन, ब्रीज, बहुत कुछ है. तुम पहाड़ चढ़ जाओ, अब एटमॉस्फेयर ऊपर की तरफ जा रहे हो, ऊपर की तरफ जा रहे हो, तो टेम्परेचर फिर वेरी कर जाएगा. सो ऑब्वियसली यू वुड नो दैट योर टेम्परेचर इज अ फंक्शन ऑफ एक्स, वाई एंड जेड, इजंट इट? So temperature is a scalar field. It depends on x and y and z. Now, if somebody is interested in saying how the temperature varies along z with height, so what you need to know, you have to tell him this particular quantity, isn't it? तुम ये बोलोगे कि फंक्शन z के रेस्पेक्ट में कैसे चेंज हो रहा है, राइट? यही हुआ ना इसका मतलब, कि टेम्परेचर, मैं यहाँ खड़ी थी तो मैं सी के पास थी और मैं अभी माउंटेन चढ़ गई तो टेम्परेचर अलग हो गया. तुमसे कोई पूछेगा कि टेम्परेचर कैसे वेरी कर रहा है, तुम कहोगे हाँ हाँ, इट इज वेरिंग विद जेड एक्सिस, इट इज वेरिंग विद रिस्पेक्ट टू जेड. सो हाउ टू टेल दैट पर्टिकुलर थिंग, दिस इज दैट क्वांटिटी. अभी तक टोटल
ठीक है भैया.
डेरिवेटिव पढ़ रहे थे. पार्शियल डेरिवेटिव का मतलब क्या है? आप जिस पर्टिकुलर फंक्शन के रेस्पेक्ट में पार्शियल डेरिवेटिव निकालते हो, लेट्स से एक्स के रेस्पेक्ट में निकाल रहे हो, तो यू हैव टू गिव एन इंक्रीमेंट अलोंग एक्स एक्सिस. So I have given an increment along x-axis. I have not given any increment along y-axis, and I am trying to find the rate of change. So rate of change कैसे निकालते हैं? Rate of change simply डेरिवेटिव ही होता है. तो देखो डेरिवेटिव अभी हमने कैसे निकाला था पहले, सॉरी. सो पहले डेरिवेटिव हमने कैसे निकाला था? देखो ये रहा डेरिवेटिव. देखो किसी पॉइंट पे x नॉट प्लस एच माइनस एफ ऑफ एक्स नॉट डिवाइड बाई एच, ये तो वन वेरिएबल में. अब टू वेरिएबल मानते हैं. अगर टू वेरिएबल है तो देर विल बी टू वेरिएबल्स. सो इफ यू आर ओनली इंटरेस्टेड इन फाइंडिंग द rate of change along x-axis, so you have to give an increment only along x-axis. So this is what is known as your partial derivative with respect to x. So if at all this limit exists, if at all this limit exists, this represents your partial derivative with respect to x. Are you getting my point? And इसके अलावा जो दूसरा पॉइंट होगा, f of x comma y plus k minus f of x comma y upon k, limit k tends to 0, that would be equals to partial derivative with respect to y. So if at all this limit exists, if at all this limit exists, this is what you call as partial derivative with respect to x. This is what you call as partial derivative with respect to y. And in notation, these ordered pairs are nothing but grad f. याद करो, ग्रेडियंट f क्या था? किसी भी स्केलर पॉइंट फंक्शन का ग्रेडियंट क्या देता था तुम्हें? fx और fy. ग्रेडियंट से क्या होता था? आपका फंक्शन किस में कन्वर्ट होता था? एक वेक्टर फील्ड में कन्वर्ट होता था. आपका कोई भी स्केलर फील्ड फंक्शन वेक्टर फील्ड में कन्वर्ट हो जाएगा. देखो वेक्टर फील्ड फंक्शन यहाँ देख, तुम्हारे पास टपल्स हैं, दो वेरिएबल्स. यस और नो? एकदम शांति क्यों छा गई यार?
यस भैया.
है ना? ठीक है, थैंक यू. ओके, सो अभी हम पढ़ रहे हैं आगे. ओके, सो लेट अस ट्राई टू अंडरस्टैंड हाउ कॉशी रीमन कंडीशंस. बस इसलिए क्योंकि ये थोड़ा सा तुम्हें एक आइडिया लगेगा चीजों का, अदरवाइज नहीं भी कराऊंगा तो भी काम चल जाएगा इसमें. बस जस्ट ट्राई टू अंडरस्टैंड. ठीक है, लेट्स से आई एम एट अ पॉइंट z. आई हैव टू मूव टू अ पॉइंट z प्लस डेल्टा z. तो डेल्टा z तक मूव करने के दो तरीके क्या हो सकते हैं? या तो आप इसके अलॉन्ग मूव करके यूं आ जाओ, या आप क्या करो, इसके अलॉन्ग मूव करके यहाँ पे आ जाओ. देयर कैन बी टू वेज. ओके, सो देयर कैन बी टू वेज. ओके, तो ये मैं क्यों कर रहा हूँ? z और z प्लस डेल्टा z ऐसे करते हैं हम. देखो ऊपर हमने अभी भी देखा, वी हैव फाउंड दैट यू व्हेनेवर यू हैव टू फाइंड द डिफरेंशिएबिलिटी इन दिस थिंग, दिस इज व्हाट यू हैव टू फाइंड, दिस इज व्हाट यू हैव टू फाइंड. ओके, so f of z plus delta z minus f of z divided by delta z tends to 0. This is the limit that we need to find. Okay, yes or no? क्या हो गया? सब है कि नहीं है? आज मर गए सब के सब?
Yes, sir.
चलो धन्यवाद.
Yes, sir.
Okay, so if you go by this way, if you go by this way, in any of these way, if you want to go, your limit should be unique. what I want to say, if f dash z exists, then this limit delta z tends to 0, f of z plus delta z minus f of z divided by delta z should be a unique path independent limit. Yes or no? Yes. So for any general point, what would be z plus delta z? Z plus delta z would be x plus delta x plus iota y plus delta y. Yes or no? And if I want to evaluate f z plus delta z, what would it be equal to? ये किसके बराबर होगा बेटा? It will be equals to u x plus delta x मानते हो, comma y plus delta y plus iota v x plus delta x comma y plus delta y. हाँ या ना? And
Yes,
if at
sir.
all I want to write f dash z, what would be your f dash z? So f dash z would be equals to what? F dash z would be equals to वापस वही limit delta z tends to 0, वो जो मैंने अभी ऊपर लिखा. So I don't want to write it all over again. So this will be it. Okay. So what it would be equal to, मैं यहाँ लिख देता हूँ. अब इसको थोड़ा ध्यान से लिखते हैं. X plus delta x, comma y plus delta y plus iota v x plus delta x, comma y plus delta y minus u as a function of x comma y minus iota v as a function of x comma y divided by delta x plus iota delta y. Yes or no? So if I'm saying my delta z tends to 0, it implies delta x tends to 0 and delta y tends to 0. Yes or no? हाँ या ना?
Yes.
अब दो पॉसिबिलिटीज अगेन, जैसे भी हमने थोड़ी देर पहले क्वेश्चन किया था, मैंने इसलिए उसको इस तरीके से कराया था. व्हाट वी कैन डू, either we can do one thing, I can keep my delta x to be equal to 0, that is I can approach in this fashion and keep delta y tends to 0. One of the ways can be this, by delta x tends to 0 होना चाहिए, delta y tends to 0 होना चाहिए, you keep delta x equal to 0, मतलब you are approaching the point along any line which is parallel to y axis and you keep delta y tends to 0. दोनों 0 की तरफ ही जा रहे हैं, इनफैक्ट वन को 0 कर दिया और एक को टुवर्ड्स. yes or no? और दूसरा तरीका क्या हो सकता है, you can move along this parallel to x-axis. When you move along parallel to x-axis, your delta y would be 0 and your delta x tends to 0. Yes or no? These can be two possibilities. There may be different other possibilities. I'm just trying to say कि if at all your limit exists, that is, if at all ये limit exists, मैं कह रहा हूँ कि function क्या है, differentiable है. I'm saying that my function is differentiable. I'm saying that my function is differentiable. That implies this limit exists. This limit exists irrespective of what path I take. Yes or no? So if my limit exists irrespective of what all path I take, I would say that if limit exists, whether I take this path or whether I take this path, it means one and the same thing. Yes or no? सोच के जवाब दो. हाँ या ना? बच्चों कुछ तो बोलो यार. क्या हो गया, सब मर गए. अल्पना समझ में आया नहीं है?
हाँ भैया.
ठीक है. भरत को समझ में आया नहीं है?
Yes, sir.
दीक्षा, गोपाल,
Yes, sir.
मोनिका, प्रज्ञा,
नहीं
कोशिश करो
भैया.
समझने की ना. मतलब कोई भी पाथ के लॉन्ग जाओगे, देखो ना मैं क्या कह रहा हूँ कि फंक्शन डिफरेंशिएबल है. फंक्शन डिफरेंशिएबल है मतलब फर्स्ट डेरिवेटिव एग्जिस्ट कर रहा है, मतलब ये एग्जिस्ट कर रहा है इररिस्पेक्टिव ऑफ व्हाट ऑल पाथ आई टेक. सो कोई भी पाथ लो. सो मैं सिंप्लिसिटी के लिए ये पाथ ले रहा हूँ कि भाई एक बार मैंने क्या किया, मेरे को इसको अप्रोच करना है तो अलोंग दिस वे अप्रोच कर लूं, और एक बार मैंने कहा अच्छा इसको अप्रोच करना है तो अलोंग दिस वे अप्रोच. चलेगा?
Yes, sir.
ठीक है जी. तो मैं ये कहने की कोशिश करूँ, अब ये मैं सिंपलिसिटी के लिए ले रहा हूँ. क्यों? क्योंकि भाई मैं पहले ही कह चुका हूँ कि मेरा जो फंक्शन है वो डिफरेंशिएबल है, तो कोई भी पाथ के अलोंग जाओ, लिमिट यूनिक है नहीं. तो मैं कह रहा हूँ व्हाई नॉट टेक दीज टू पाथ्स. ठीक है, let us try to take these two paths. So if I take these two paths, so let's say if I'm taking the first path, so if I take the first path, what is happening? So if I take the first path, delta x is equal to 0. So what it will yield me? It will yield me delta y tends to 0. This is your x comma y plus delta y plus iota v x. This is what it is, right? Minus u x comma y minus iota v x comma y. This is for your path 1. हाँ या ना? देखो डेल्टा एक्स तो 0 ही है, देखो दिस इज इट। सो थोड़ा ध्यान से देखते हैं, व्हाट इज दिस, ये वाला 1 और 2, गिव मी, जस्ट थिंक अबाउट दिस, and just think about this, just think about these two uh, terms. So if I think about these two terms, what it is, this is x plus delta x, sorry, x comma y plus delta y minus ux comma y, and 1 upon iota you keep outside so that it does not gives you any sort of trouble, divided by delta y, हाँ या ना? And then this is along path 1, ठीक है, and plus v x comma y plus delta y minus vx comma y divided by delta y, and delta y tends to 0. Remember this limit, delta y tends to 0. Okay, yes or no? So what you will
Yes.
Yes,
get,
भैया।
ये देखो इसमें क्या हो रहा है, यहाँ पे x में कोई इंक्रीमेंट नहीं दिया है, y में इंक्रीमेंट दिया है, तो ये पूरी चीज क्या हो जाएगी, ये पूरी चीज क्या, पार्शियल डेरिवेटिव ऑफ u विद रिस्पेक्ट टू y नहीं हो जाएगी? अभी अभी बताया मैंने, आपने y में इंक्रीमेंट दिया, एंड 1 अपॉन आयोटा क्या होता है, माइनस आयोटा। और सिमिलरली इस चीज को देखो, यहाँ पे y में इंक्रीमेंट दे रखा है, x में नहीं दे रखा है, तो ये y के अलोंग रेट ऑफ चेंज नहीं हो जाएगा v का? थोड़ा ध्यान से सोचो, अभी अभी बताया मैंने पार्शियल डेरिवेटिव विद रिस्पेक्ट, पार्शियल डेरिवेटिव्स की डेफिनेशन इसलिए मैंने बताई थी, तुम देखो पीछे y में इंक्रीमेंट दे रखा है, और ये k इंक्रीमेंट था और k टेंस टू 0, तो ये क्या होता है, पार्शियल डेरिवेटिव विद रिस्पेक्ट टू y फंक्शन का। सिमिलरली यहाँ ध्यान से देखो, यहाँ पे क्या दे रखा है, u x कॉमा y प्लस डेल्टा y माइनस यू एक्स कॉमा वाई डिवाइडेड बाय डेल्टा वाई टेंस टू 0, तो इवेंचुअली यही आएगा पाथ 1 के लॉन्ग, हाँ या ना? सोचो
हाँ भैया।
पाथ 2 के लॉन्ग क्या होगा, थोड़ा सोचते हैं, डेल्टा एक्स टेंस टू 0 है, डेल्टा वाई 0 है, तो ये क्या हो जाएगा, डेल्टा एक्स टेंस टू 0, दिस इज योर यू एक्स प्लस डेल्टा एक्स कॉमा वाई माइनस यू, पहले एक बार ढंग से लिख देते हैं, तो फिर एक बार गलती होना चालू होगी तो गलती होती रहेगी, वी सॉरी, ओके, जस्ट गिव मी अ मिनट। Okay, so what it will yield me, this will yield me, sorry, this will yield me x, sorry, x plus क्या था ये, कहाँ गया, just give me a minute, okay, ठीक है, so what it will yield me, x plus, sorry, x
Delta x
plus
comma y.
delta x comma y, ठीक है, minus u x plus delta x comma y minus iota v x plus delta x comma, if I'm not wrong, acha, x comma y then, sorry, so that would not
Yes.
be, sorry, my bad. Okay, so this is it, okay, divided by, I think, delta x, divided by delta x. I hope it is clear, यहाँ तक समझ में आया बेटा? So what it will yield me, it will yield me, you see, अब यहाँ से आप ऊपर से थोड़ा सा ध्यान से देखने की कोशिश करो, just consider these two terms. So यहाँ पे किस में इंक्रीमेंट दिख रहा है, x में, ux plus delta x comma y minus ux comma y divided by delta x tends to 0, so this is your del u upon del x, मानते हो? ये पहले दो टर्म्स हमने टिक किए, और ये वाले टर्म्स
Yes.
देखो ध्यान से, इन दोनों टर्म्स को देखो, ये दोनों टर्म्स क्या है, थोड़ा ध्यान से देखेंगे तो ये दोनों टर्म्स क्या है, यहाँ पर भी x में इंक्रीमेंट है, तो दिस इज योर आयोटा del v upon del x. Now, if your function is differentiable, then whether you go by path 1, whether you go by path 2, the limit should be unique. That implies anyway these two limits should be equal. So if I equalize these two limits, so minus iota del u upon del y plus del v upon del y is equals to del u over del x plus iota del v upon del x. Yes or no? So if you equate these two terms, what do you get? You get your Cauchy-Riemann conditions. Yes or no? So ये मेरे को बताना था, इसलिए मैंने बताया कि देखो पाथ इंडिपेंडेंस कितनी जरूरी है, पाथ इंडिपेंडेंस की वजह से यू आर एबल टू एक्सट्रैक्ट दीस Cauchy-Riemann conditions. So your real part gets equated to real part and your imaginary part gets equated to imaginary part. So these are two nothing, but these are equals to Cauchy-Riemann conditions. Okay, so understand the point that if your function is differentiable, then your Cauchy-Riemann conditions are met. Yes or no? देखो अभी भी हमने क्या लिया, हमारा इनिशियल प्रेमाइस क्या था कि हमारा फंक्शन जो है वो डिफरेंशिएबल. So if our function is differentiable, then my Cauchy-Riemann conditions will be met. Yes or no?
Yes, sir.
Okay. In next lecture we are going to consider थोड़े से और इसमें difficulties, but do understand this point. Okay, यहाँ तक कोई दिक्कत? Now,
Sir, ये
does
सब
it imply that if your Cauchy-Riemann conditions are met, your function fz is differentiable? So अभी मैंने जो बोला या जो मैंने derive किया तुम लोगों के लिए, I told you that my function is differentiable, then my Cauchy-Riemann conditions are met. And if I'm saying if my Cauchy-Riemann conditions are met, does it imply my function fz is differentiable? So this is what we are going to see in the next class, and today itself we are going to finish this off. So ऐसा just keep patience ना, अभी हम करेंगे questions भी करेंगे, but just keep patience. अभी इस पूरे lesson की learning क्या है? You have to understand that if your function is differentiable, then your Cauchy-Riemann conditions are met first. And इससे पहले हमने क्या पढ़ा था? Always remember that in complex analysis, whether you discuss limits, whether you discuss continuity, but the only point that is the caveat around it is the path independence. If your limit does not adhere to path independence, your function will not be having limit at that particular point where it is asked. Or for example, if I'm saying my function is continuous at point z equal to z naught, then the limiting value of the function at z equals to z naught must be equal to f of z naught, and further the limit should be path independent. So these two things you should keep in mind. Differentiability, I've already told you, it goes this way. And also remember, in differentiability also, you cannot have path dependence. So again, differentiability also holds only if the limit is path independent. Further we moved, if the function fz is differentiable, that is f dash that exists, and fz is given by u plus iota v, then always remember Cauchy-Riemann conditions are met. And I'm leaving you with the question that if your Cauchy-Riemann conditions are met, does it imply that your function fz is differentiable? We'll try to see this in the next lecture. And mostly I would finish this particular portion in the next lecture, so go attend it. Okay.
Sir.
Okay. So,
Hello, sir.
हाँ बेटा.
सर एक क्वेश्चन.
अभी क्वेश्चन तो बोलेगा उतने में खत्म हो जाएगा, पर भी एक बार बोल ले. अब बोल.
सर बस ये था कि ये सब चीजें 3 डायमेंशन में भी ट्रू है क्या?
हाँ बेटा, क्या बोल रहा है 3 डायमेंशन में?
जो हम लिमिट एग्जिस्ट निकाल रहे हैं, जैसे 1D से हम 2D में लेफ्ट और राइट हम पहले लिमिट चेक करते थे, फिर 2D में हमने अलग अलग स्लोप के थ्रू देखा कि अलग अलग आ रही थी लिमिट. तो वैसे 3 डायमेंशन में भी ट्रू
हाँ
है
हाँ
क्या ये सब चीज?
बिल्कुल बिल्कुल. इनफैक्ट ये n डायमेंशंस में ट्रू है. ठीक है. So but for that n dimension you'll have to have a linear algebraic formalism. So probably that is way beyond your course. But I will try my level best. धीरे धीरे हम बढ़ेंगे आगे. होता है exactly. It happens. So multivariate calculus we extended to Rn.